I'm going to talk about polygons, including congruency, regularity, and area. Let me start by stating what polygons are. Polygons are figures in a plane with straight line segment edges. All right, some examples. So a triangle is a figure in a plane with straight line segment edges. So is a rectangle. And you can have more complex examples. All right. Now let me show you one way that you can denote specific polygons. All right, give me a second to label all the vertices of my examples. Okay, so you can denote the first example, the triangle, by using a triangle symbol and then listing the vertices right after that, the names of the vertices. So triangle ABC, as I've shown there in purple. The next one maybe with a rectangle symbol and then listing the vertices after that. Okay, now admittedly, once you get to more complicated polygons, for various reasons you might not be able to have a little symbol. So some textbooks, some people will simply list the vertices. So they'll refer to, for example, the last example as polygon HIJKL. Okay, that happens to be a polygon with 5 edges. So if you can put a symbol, if you can put a little figure of a polygon with 5 edges, that would be quite nice. But as I said, not everybody does that. All right? Now let me mention a little bit about congruency with respect to polygons. Okay, so polygons are congruent if all corresponding sides and angles are congruent. So let me draw an example. So I have there 2 polygons with 5 sides. Now, if they are congruent, then corresponding sides all have the same length. Okay? And furthermore, corresponding angles all have the same measure. And as you can see, when you have lots of angles, it can get a little tricky to denote that they all have the same measure. Okay? So when you think about congruent polygons, think about corresponding sides and angles being congruent. Now, let me tell you some common names for some common types of polygons. So a triangle refers to a polygon with one side, with 3 sides. A quadrilateral refers to a polygon with 4 sides. A pentagon refers to a polygon with 5 sides. Then we have hexagons, and then septagons, and octagons. Probably the most familiar octagon-shaped object in your life is stop signs. Stop signs have an octagon shape. Now, what about for polygons that have more sides? Okay, for polygons that have more sides, and even for these, if you forget the names, you can refer to polygons simply by the number of sides with a suffix gon tacked on. So, for example, a polygon with 12 sides, you might denote it by 12gon. A polygon with 40 sides, 40gon. All right, so you get the idea. Now, let me define what it means to say that a polygon possesses the property of regularity. Okay, or people will say that a polygon is regular. So let me state what that means right now so that there's no misunderstanding. I'll type it out. A polygon is regular when all sides are congruent and all angles are congruent. So the ancient Greeks were fascinated with regular polygons. So a regular triangle would be one where all the sides were congruent and all the angles were congruent. So you may notice that the measures of all the angles would have to be 60 degrees. Okay? A regular quadrilateral would be a square, because a square has all sides congruent. And you'll notice that all the measures of that regular polygon are 90 degrees. Okay? Now let me make a comment about areas of polygons. So you may know the formula for the area for the areas of some simple polygons. All right? For more complicated polygons, and even to derive the formulas for simple polygons, I would suggest breaking up polygons into simpler pieces. So here's an example, and we'll close with this one. Suppose you had a pentagon that looked like the silhouette of a house. Okay? So instead of running around looking for a formula for a pentagon in the shape of a house, what about dividing the pentagon into a rectangle and a triangle? Okay? Then you only have to remember the rectangle area formula and the triangle area formula. Okay? Use those, add the results together, and now you have the area of this polygon.